together. So we're going to actually go through this piece by piece. So we're going to see how you did. So initially, when they've given the equation to us, we want to check and see that it is then in factored form with a parentheses. So that is what we have to have in order to find our x-intercept. Now the thing is that now that we have all these different factoring methods and techniques, is that if you did have something that wasn't factored, you have a lot of different skills now for how you can get it factored. When I give you this question on the test, it's already going to be factored, just like this one, but just for the sake of thinking about these problems, we could factor it if we needed to. So we want to think about this in 3 pieces. So we want to, I like to think about isolating each piece that involves the variable x. And so I'm just going to use some colors here to help separate this into those 3 pieces. Now, each one is going to correspond to its own x-intercept. Now, technically what is happening here to get the x-intercept, those are the solutions to setting that piece equal to 0 and solving for x. We just did a ton of work with this recently when we talked about finding zeros. Well, those are the x-intercepts. So we can see here that our first x-intercept is going to be 0. We'll go ahead and write it as an ordered pair. You'll do this on the test as well, so go ahead and write this as 0, 0. Now the multiplicity is the name for the exponent attached to it. Now if you don't see an exponent, we know that it's really an invisible 1 there. And because it's a 1, that tells us that it's going to cross through. Now, if we look at the second piece here, so thinking about x plus 5 being equal to 0 and solving for x, we're going to have to change to the opposite sign. We're subtracting 5 from both sides. So the second x-intercept we have here is negative 5. As an ordered pair, it's going to be negative 5, comma 0. Now, this one has a multiplicity of 2 because that's the exponent attached to that part. And because it is an even multiplicity, that tells us that it's going to bounce. All right, the last one up here for the x minus 3 part, we're going to have to add 3 to both sides, so we end up getting positive 3 for our last x-intercept. Now we can see the multiplicity up here is also 3, that's the exponent, and because it's an odd multiplicity but greater than 1, that's going to wiggle. So this one's kind of nice because here we're getting an example, one of each type of situation. All right, when it comes time here to think about our end behaviors, it's going to be based on the leading coefficient and the degree. So the leading coefficient is really just whatever's in front of the whole entire thing. In this case, we don't see anything, so it's a positive 1 out in front. But then to find the degree, because this one is in factored form, we are going to add the exponents that we see. So we're adding together 1 plus 2 plus 3. We're only adding them because it's in factored form. And because the leading coefficient is positive and the degree is even, that puts us in the category of our end behavior being of up. So we still need to know and be very familiar with those 4 end behavior situations so that we can answer this part of the question. All right, now thinking about getting the y-intercept, all we need to do here is plug in 0 for x and solve for y. Now, one thing that we can notice right here at the start is that we have a 0 multiplied at the very beginning. And we know that 0 times anything is equal to 0. So we actually don't need to even think about the process of like PEMDAS and let's start to simplify these parentheses down and then apply the exponents. We actually don't need to do that because the whole thing is going to be equal to 0. Another interesting fact, we've talked about this before, is that if you ever have an x-intercept of 0, 0, your y-intercept is also 0, 0. All right, so now we're going to put all the pieces together to go ahead and sketch our graph. So we knew that we had an x-intercept at 0, 0, and we saw that it was going to cross through. We have an x-intercept at negative 5. Hold on, my pen and my board just died. I wonder if this thing is not charging. It says that it's super low battery, and it's like only been plugged in. Let me see if I can get it to work on this board. There we go. That'll work. All right, so at negative 5, it's going to bounce, and then at positive 3, we saw that it was going to wiggle. together, so our end behavior is going to be up, up, so I like to set up the arrows like that, just a little bit on the outside. That's going to help guide our curve as we start to draw in the inside. So on the left here, so it's going to come down. Bounce just means that it's going to touch and turn around. And then we need to have a turning point so that it can cross through the next x-intercept. And when it crosses through, we just want this part through the x-intercept to be like pretty straight. If we were to zoom in on that, it would almost maybe look like a linear straight line. And then notice that we need to wiggle through the last one, so we need to have one more turning point so it can come back. And my best advice for doing the wiggle is to come up a little before the x-intercept so you can go flat, and then continue a little bit afterwards. So what I'm looking for on your wiggle is that I can tell that there's a little bit of a bend in the line, and that it's not just perfectly straight through.